Good morning, everyone. This is the first lecture in a brand new year, and this is ray optics. There are students online as well as offline, and I welcome all of you to today's class. Well, what we are going to do today, the camera has gone from everywhere, is we will start with
And what
ray
about circular motion?
ray optics. Circular motion. You are
Fluid
supposed to.
dynamics. We have covered up to motion confined to circular path.
Okay, that was last year.
Previous Ola.
That was last year. Is that so?
Yes, sir.
Okay, I will. What I'll do is I'll talk to the office people and ask what is to be done because right now I've been advised to take ray optics. So let's start with this. I will probably get over with that thing after
Okay,
we
sir.
are done with this. Don't worry.
Okay,
Don't
sir.
worry. We'll cover everything out. Okay. So we'll cover it up. Let us first start with this one, as it has been said that we need to cover this one first. So this is ray optics, lecture number 1. Now I can't see you guys, so that's a problem. The camera is not working, but still, let us try to interact in whatever way it is possible. Optics. Optics is a branch of physics. We have heard about various branches in physics. We have dealt with mechanics. I think we have dealt with thermodynamics as well. In the other class, I think electro is going on, electromagnetism. Then there is this branch, optics, which deals with the study of light. I hope you know this. Now, as soon as we talk about light, we must understand the nature of light. I hope you know about light and the nature of light. Yes or no, everyone? Light.
Yes, sir.
What type of nature light has? Yeah, can you tell me what type of nature light has? Hmm? Have you heard about this statement that light has dual nature? Light has dual nature. Have you heard? Students in the class, have you heard this? Light has dual nature. Yes or no? Abhiram says yes. What about the others in the class? I mean, anyone can represent them and let me know. Light has dual nature. Now, when
Electromagnetic nature, sir.
electromagnetic nature, okay, a new term has come. Light has a electromagnetic nature. Okay, light is a EM wave. We will cover this topic of EM wave as well. But right now, I'm not very concerned about the electromagnetic nature of light. Basically, light consists of electric field and magnetic fields combined, and light is propagating. We are still studying electric field and magnetic field, so let us not get into this EM wave. Okay, it's a EM wave. Yes, we will get to know about this. But right now, I'm concerned with something else. When I say light has dual nature, okay, what we have done in physics is that in physics, anything that we see belongs to any one of these categories. Okay, you will say, sir, some things are living and some things are non-living. This is how you can classify whatever you see in the universe. Yes, living, non-living. That is one way of classifying whatever you see in the universe. There's also one more way in which you can classify what you see, physical objects or physical attributes. It's a particle nature or a wave nature. Yes, Abhiram is correct. Wave nature or particle, wave and particle. So whether Whatever you talk about, it will fall in either one of these categories. Either it will be a wave or it will be a particle. Now, what is the difference between a wave and a particle? Wave is a wave, particle is a particle. You can say this, but what is the difference theoretically? Can anyone explain? What do you mean by a wave and what do you mean by a particle? What could be the difference between a wave and a particle? Anyone in the class can tell me what is the difference between a wave and a particle? Now, if I just draw it to make you understand, a wave. I think we dealt with wave. A wave looks something like this. A particle.
Particle in a quantum nature. It travels in
Particle has got a quantum nature. Okay. Okay.
small packets.
Yes, packet. So if something is a particle, it is not continuous. We can call it discrete. Do we understand discrete or quantums? Yes or no? A packet of biscuit is discrete quantity. It's not continuous. One packet, two packet, one mobile phone, two mobile phones. They're in packets. One sir, two sir, three sir. Packets. Discrete quantities are wave, are particles. So whenever you have discrete quantities or something behaving as a discrete quantity, for example, a large number of electrons are striking a surface. We will see about that in X-rays and all types of things. Large number of particles striking a wall. You have a water gun and you are striking a wall with a water gun. Small particles hitting the wall or large number of particles hitting something, that will create an impact. Now that nature, because everything is hitting as one packet, that is known as the particle nature. Discrete quantities. Now when you talk about waves, as you can see, wave is a continuous thing. Continuous. Wave is always continuous. You see water waves, you see any type of wave, it is always continuous. It does not happen one thing, then thing. That this is not a wave, this is a pulse that you see. It comes, comes. Wave. Wave is continuous. So if any particle, any body is having a continuous nature, then it's known as the wave nature. We, as individual, we are probably more particles than waves. Now we understand that everything can have dual nature. Which nature will be more, we will see, don't worry. So when you talk about light, in some cases it behaves as wave, in some cases it behaves as particle. Now that might not be correct to say. There are certain phenomena of light which we'll have to explain, and these are the phenomena that we are going to study in this chapter of ray optics, or for that matter wave optics. What are the different phenomena that we have to study in this chapter of optics? Can anyone tell me what are the different things that we have to study in this chapter? Anyone has any idea? Class 1, class 2? What are the things that we are going to study in this chapter and all? We are going to study phenomena like reflection. Have you heard about the term reflection? Yes or no, bacha?
Reflection, refraction,
Reflection, refraction, anything else?
rhythm,
Yes?
rhythm,
Rhythm, prism. Okay. We are going to study polarization. Have you heard about this term, polarization?
yes sir,
Okay. We are going to study a term known as interference. Have you heard about the term interference?
yes sir,
Then we are going to hear the study the term photoelectric effect of light. Have you heard this term?
yes sir,
So these are in short certain phenomena that we are going to study in this particular chapter. Now, some of these phenomena can be explained both by wave and the particle nature. So if I talk about reflection and refraction, we can understand reflection and refraction both by considering light as a wave or light as a particle. But there are certain phenomena which can only be explained by one nature of light. For example, interference. Interference of light can only be explained by the wave nature of light. Similarly, the photoelectric effect, the green one, can only be explained by particle nature of light. That is why we call sometimes light behaves as wave, sometimes light behaves as particle. When we say that, what we actually mean is certain phenomena that light exhibits can only be studied or understood by wave nature. Some phenomena can only be understood by particle nature, but some phenomena can be understood both by particle as well as wave nature, and that is the phenomena that we are going to start off this particular chapter. We are going to start with reflection and refraction of light. I hope all of you understand this, yes or no? This reflection or refraction of light can be explained by both wave as well as particle nature. You think of light as coming in packets, small packets. You can understand reflection. You can understand light coming as wave. Then you can also understand how it is going to get reflected or refracted. So that is how we will start our life with the phenomena of reflection and refraction. Is everyone ready? Can I have what should I say? I can't see you. So can you have some raise hands from everyone that we are ready? And we
Yes,
have
sir.
remember, you will have to make notes for yourself. Your notes must be good, because these are the notes that are going to help you out. So whatever I am saying, I hope everyone is noting it down. So now we come to the part where we are going to write our first heading, and our first heading is definitely what? Our first heading is definitely reflection of light. And this is what everyone will write, reflection of light. Now, everyone would have seen reflection. We see it in day-to-day life. You must be knowing what is a reflection. Can anyone tell me what do you mean by reflection? Anyone from any class who has a mic, who can speak? Yes, better. Reflection. Anyone? No one knows what is reflection? No?
Bouncing back of light.
Bouncing back of light. What do you mean by bouncing back of light? Yes, that is correct. That is correct. I mean, you are definitely correct. No, wrong. Bouncing back of light. From where? What bouncing? Can you explain in more detail what do you mean by bouncing of light?
Cylinder passing from reflected in the same medium.
The lights get reflected in the same medium. See, when you are trying to define reflection, you cannot use the term reflected in the definition of reflection. Reflection means light is getting reflected back. Well, that will not make much sense. So bouncing is the right word, because to make you understand a term, we must use simpler terms. We cannot use reflection to understand reflection, because then it will not be making much of a sense. Okay, let us take an example. Let us take this line. Now, what is this line? This line is nothing but boundary. Boundary between what? Here you have one medium, here you have the second medium. So you have a boundary between two mediums. The best example for this would be, look at the surface of any lake or any pond. So above your lake, you have air, and inside the lake, oh, you have water. So air becomes your first medium and water becomes your second medium. Do we understand this? So if you have a boundary between two mediums, that is how we can understand reflection very correctly. Either you have boundary between two mediums, or you have something where you do it like this so that nothing will go past this. So you have a surface, you have a reflecting surface, you have a mirror, you have anything that reflects back, anything that will help light bouncing back. The simplest way in which I can define reflection is by using the term boundary, because that is how it is defined. So you have a boundary between two mediums. Now, if light is falling on that boundary, if light is falling on that boundary, this is known as the incident ray, and this is known as the angle of incidence. I hope all of you understand this. If light is falling on a boundary between two mediums, a part of it is going to be reflected or bounces back in the same medium. This bouncing back of light in the same medium, when it strikes boundary between two mediums, or it strikes a surface, is known as reflection. This is the best and the most appropriate definition of reflection. Whenever light strikes boundary between two mediums, or it strikes any surface, a part of it bounces back, comes back, turns back into the same medium. This phenomena is known as reflection of light. Do we understand this, everyone?
Yes, sir.
Okay. So this is what you will write. What do you mean by reflection of light? This is what you will write. The phenomena of bouncing back of light, the phenomena of bouncing back of light, the phenomena of bouncing back of light, the phenomena of bouncing back of light in the same medium, in the same medium it strikes when it strikes a boundary or a surface. When it strikes a boundary or a surface, this phenomena is known as reflection. I hope all of you have understood this. Yes or no? I don't think anyone would have doubts on this. Now, when you are trying to understand this phenomena of reflection, there are certain things that you must understand, certain points. O. What is this point O known as? I hope you know this. Everyone knows this, right? What is this point O known as? You will have to mark this in your notebooks. Every small things, every small detail, because after some time, these details are going to come, and if you understand them correctly, you will be able to understand the topic correctly. What is this point O known as? The class which I can see, which has a running camera but not a running mic. Origin. No, it's not the origin. Why should I call it the origin? What is O? What is happening at the point O? That is what you see, and that is how you name it. What is happening at the point O? At the point O, light is striking. So point O is known as. Someone was saying something. I could not hear it. Point O is known as. Say. Point O is known as what? Don't have a mic. Scarcity of resources. Not a good thing in life. Should be having a mic. It works. Okay, let me help you out. Point O is known as the point of incidence. It's a very simple thing to understand. Point of incidence, and I hope everyone is writing. Point of incidence. This is the point where something is incident. What is incident? Is this thing. And this ray is known as? Yes, everyone knows this.
Incident ray.
Yes, this ray is known as the incident ray. So, point of incidence is the point where the incident ray strikes the surface, or it strikes the boundary between two mediums. Incident ray is the ray which is striking. The point where it strikes is known as the point of incidence, which in this case is the black O. Then you have reflected ray, the ray which bounces back. The red ray is known as the reflected ray. Then I have one more, this black khach. What is this black khach, which I have written as N?
Normal.
Yes, this is the normal to the surface or the boundary at the point of incidence. Remember the meaning of the term and correctly. Normal is always drawn at the point O, not at any other point. Do we understand this? So N is the normal. It is perpendicular. It is a perpendicular which is drawn to the boundary. This is the boundary or the surface. This is the point of incidence. To draw a perpendicular at this point, that is known as the normal. All of us understand this, yes or no? The camera goes away again. We are having troubles with the cameras, but we are not having troubles with the spirit that we have. Okay, so everyone has noted down this simple diagram? Yes or no? Yes.
Yes, sir.
When I can see you, I can at least see your raised hand, so that gives me faith that God exists, and my voice is getting on the other side. It's important that God exists. Okay, now since we know this, since we know that the fundamentals of reflection, then we must also know the two laws of reflection. Everyone understands those two laws of reflection. Can anyone tell me what are those two laws of reflection? What are those two laws of reflection?
Incident ray normal and in reflected ray lies in the same plane.
Okay, that might be the first. That might be the second law. The first law is a very simpler one. Probably you would have heard about this. The angle of incidence
Of incidence equals to angle of.
and the angle of reflection both are equal. We all know this, yes or no?
Yes, sir.
Okay, but again, you must also understand what do you mean by angle of incidence. Angle of incidence is the angle between the incident ray and the normal. We all understand this. What is angle of incidence? I have noted it as I here. Angle of incidence, if you don't know, you can also write this. This angle of incidence is the angle between the incident ray I and the normal N. That is known as the incident angle. Remember, incident angle is not taken with the boundary. It is not the angle with the boundary. It is the angle with the normal on the boundary. Similarly, angle of reflection is again not the angle that the ray makes with the boundary. It is the angle that the ray makes with the normal. Do we all understand this? Yes or no? We understand this? Because sometimes a question will
Yeah.
come where instead of giving you I, they will give you the angle with the surface. So they will frame a question where incident ray makes an angle of 30 degree with the surface. What will be the angle of incidence? In that case, 30 degree is
60.
not the angle of incidence. 60 degree will be the angle of incidence because it is the angle that is made with the normal. And that is why you must remember all these definitions correctly. Do we remember these definitions correctly? Yes or no?
Yes, sir.
Okay, then we must go and write the first law of reflection. What is the first law of reflection? Angle I will be equal to angle R. I hope everyone understands this. Yes or no? Then what is the second law of reflection? That was what he said. What is the second law of reflection, beta? These three rays, they lie in the same plane. Which three rays? The incident ray I, the reflected ray R, and the normal all lie in the same plane. Do we understand this? Do we understand this? Okay. Now, there are some important points that you must remember about reflection. So, you will note them down. Remember, whatever each and every point that we are discussing in the class must be there in your notebooks at all cost, because any one of these points will be appearing in the examination hall, and then you must not be found lagging. I hope all of you are noting everything in the class very religiously from the very first day. Yes or no? Okay, so this is what we have discussed, and I'll show you a part of the sheet with proper diagrams. Here it comes. You can see the incident ray. You can see the normal, you can see the reflected ray. This is the boundary between two mediums. We have seen angle I is equal to angle R. Now we have to note down the other points. I hope you know whatever terms are used here. After reflection, I want you to write it. After reflection, remember the incident ray and reflected ray, both are in the same medium. The ray is getting bounced back in the same medium. After reflection, which quantities remain same and which quantities they will change? The question will come. So please remember, what all quantities of the light which will remain same? The velocity of light will remain same. The wavelength of light will remain same. They are remaining same because it is in the same medium. The frequency of light will remain same. Frequency of light normally always remains same unless and until there is a Doppler effect. Even in Doppler effect, the original frequency remains same. Frequency depends on the source which is creating light. Unless and until you change the source, the frequency will remain same. The thing that changes here is the intensity of light. Intensity is the amount of energy that is falling per unit area, per unit time. Remember, even if we have a perfectly reflecting surface, not 100% of the light is reflected back. Some amount of light is absorbed, some amount of light is transmitted. We will see those terms, don't worry. Some amount of light is reflected, some amount is absorbed, some amount is transmitted. Therefore, the intensity of light after reflection or refraction will always decrease. Can you remember this? Yes or no? Do you understand this? I don't think you would have heard the term intensity. Intensity is nothing but, in short, energy per unit area per unit time. So that quantity will decrease. Velocity will remain same, wavelength will remain same, frequency will remain same, intensity changes. There is one more thing that might change or that might not change. That is known as the phase of the wave. Phase. Phase of the wave. Now you might not be knowing this term phase of the wave. So have you heard the phase change of the wave in the chapter known as wave motion in the previous year? Did you do the chapter wave motion previous year? Yes or no, beta? No?
Wave motion.
You have done wave motion? Yes or no?
No, sir.
No, sir. कोई बात नहीं, sir. So there is something known as phase. We will discuss that phase in the chapter on wave optics. So we will discuss this phase change in that chapter. There we will discuss it in detail. Remember, phase of the wave depends on from which medium it is getting reflected. Rarer medium, denser medium. Now you may not know right now what is rarer medium or denser medium. So what we will do is just write phase, will phase, and just to leave two lines. So we will fill up the blanks when we understand the word phase. We will come back and then we will do it again. Okay, so leave two lines, write phase, leave two lines. What happens with the phase? We will understand it more easily, more strongly when we understand the meaning of the word phase. So then we will come back and we will do it then. Okay, got it? So right now just leave two lines and then we will come back to this one. Now, one more thing that you will have to remember, what happens if the angle of incidence is 0? Now, this angle of incidence is 0 is called by a different name. We sometimes call it that the light is incident normally on a surface. When you say light is incident normally on a surface, that means it is falling perpendicular to the surface. In this case, the angle of incidence becomes 0. Therefore, the angle of reflection also becomes 0. Or we say it in a different way. After reflection, the light will retrace its path. So remember, this is a very important thing. When does light retrace its path? When it is falling normally on any type of surface, whether it's a curved surface, whether it's a plane surface. If the light is falling normally on any surface, beta, it will always retrace its path. It will come back at the same angle. In the first diagram, I showed light falling on a plane surface. Normally, it was getting reflected back. Normally, here you have a curved surface. Here you have a curved surface. Light falling on a curved surface will also be reflected back along the same path. We call it light retracing its path. Do we understand this, everyone? Can I have raised hands from everyone that you understand this? Remember, these small things are going to make a lot of difference in the final exam beta, because on these small things, they will make questions. If you remember these things in the very first day, you will be able to solve all those difficult questions. very easily. Now there is one more case that you must see, which is known as grazing incidence. Now there might be question where you hear this term grazing incidence. Grazing incidence simply means that the light is falling like this. I hope you can see this light falling like this. That means here angle of incidence is 90 degrees. So grazing incidence means angle of incidence 90 degrees. Incident normally means angle of incidence is 0 degree. Do we understand this? Yes or no? Please note it down. Every diagram must be there in your sheet. Every diagram must be there in your notebook. And the student who makes the best diagrams, he will be doing the best stuff. I hope everyone is noting it down. Noted? Grazing incidents and incidents of normal incidents. Can I move forward? Yes or no?
No, sir.
No, sir. Okay, sir. I wait, sir. Let me know when you are done. When I say light is incident normally, I mean angle is 0. When I say light is at a grazing incidence, I mean the angle is 90 degrees. In both the cases, angle of incidence and angle of reflection are same.
Sir, once place the previous sheet,
Which previous sheet, beta?
previous slide. Sorry,
I mean,
normal incident.
what was normal? You just make one light like this falling on a surface. It will just go back like this. You want me to show it again? Okay, I'll show
Yes, sir.
both of these things again. Please note each and everything, beta, because everything that we are discussing in the class, same thing will come as question in your examination hall. So please note them clearly. Case number 1 is normal incidence, angle of incidence and reflection both are 0. Remember, we'll also do this in refraction, and then we will see the difference there. Okay, you noted it down? Shall we move further ahead in life? Life has to move on. Yes, life moves on. And then you have this small thing that you must understand. This is basically a theoretical concept. You just have to draw this diagram. Two types of reflections are there. One is known as the regular reflection and one is known as diffuse reflection. You can see diffuse reflection is not the one which is going to come more often in your exams as a question. Here, this is normal regular reflection. This is diffuse reflection. If the reflection is taking place from a perfectly plane surface, all the angle of incidence will be same and all the angle of reflection would be same. So light will be falling like this and going like this. You will have good reflection. But if you have an irregular surface, not a proper surface, at all the places, even if light is falling parallelly, angle of incidences would be different at different points. Angle of reflection would be different, and therefore we will be able to see an object from any position because of the irregularity of the surface. This type of this type of reflection is known as diffuse reflection. I hope all of us understand this. Yes or no? Very simple. You just have to draw the diagram. If the reflection is taking place from a perfectly plane surface, it is known as regular reflection. If it is taking from a zigzag sort of a surface, It is diffused reflection. Angle of incidences are different and angle of reflections are different. So this is what I call regular reflection and diffused reflection. Okay. Yes, you could not write the previous slide. First, note this down, just leave space because I'm on this slide. So first note this down and then we will go back to that slide. You want me to go back? It was very simple diagram that I had shown you. So once you note this, then I will take you back to that slide. Don't worry. Okay. Just leave small space. Draw the diagram for this one, regular and diffuse reflection, and then I will take you back to the previous one. It was very simple. Two surfaces were there. In one case, the angle of incidence was 0. In the other case, angle of incidence was 90 degrees. It was a simple diagram. Here, you don't have to write everything. You just have to draw this regular reflection. If the reflection is taking from a perfect plane surface, if you just write this line, it is more than enough. No one is going to ask. If the surface is rough, there is no regular reflection. The reflection taking place from any curved or zigzag surface is known as diffuse reflection. And then you just draw this diagram. That is more than enough that you require. I'll wait for you 2 minutes and then I'll take you back to that diagram again. We will wind up this class here. I think the time is over. Yes, beta.
Sir, in very basic classes, they tell us light travels in a straight line.
Yes.
And in the upper graduations, they tell that light travels in a wave nature or particle nature. So which is the basic understanding, sir?
Light always travels in a straight line, whether it is a wave or it is a particle, it travels in a straight line. Who says that wave cannot travel in a straight line? Wave can travel in a straight line, don't worry. Light is the electromagnetic wave, so direction of propagation is along a straight line. The electric and magnetic fields are moving in perpendicular direction. That does not affect the way light is moving. Do we get this? Motion of light has got nothing to do with the wave nature. I mean, it is going to move in a straight line unless something obstructs its path. If something obstructs its path, then we have different phenomena happening, whether it is interference or it is diffraction or any other thing. Okay, it will start to bend, So we will be doing all those phenomena. Don't worry. Right now, today's class, we just had a brief introduction as to what we were supposed to do. We saw that light has dual nature, wave as well as particle. It travels in a straight line. It is an electromagnetic wave. I will tell you some properties of light in the next class. I'll tell you those properties in the next class. It behaves as wave as well as.
Work power energy completed, sir. Work power energy.
It travels in a straight line. And we will deal with reflection. We have gone through the basic premise of reflection, the laws of reflection, the types of reflection, regular and diffuse. No one is going to ask you what is regular and what is diffuse reflection. You just have to tell you for the sake of theoretical purpose. So I'll see you in the next class. We will continue with this in the next class. Take care. Have a nice day.